For question number 60, out here, we have 8 such triangles that can be formed in the octagon. And all of these angles add up to 360. So if we were to find out 1/8 of the total 360, we would get 45 degrees. So we can individually draw out here one triangle. So this entire angle is nothing but 45, and we have R out here and R out here, and this side represents the diameter of the semicircle. So if I want to find out the radius of the semicircle, I would label this as x, and this total, which is 45, we would take the half of it. So half of 45 would give us 22.5 degrees. So sine of 22.5 is equal to x, which is the radius out here, over r, which is the radius of the larger circle. So x is equal to r times sine of 22.5. Now we find out the area of the semicircle, which is equal to half into pi r square. R out here represents the radius of the semicircle. So half times pi x square. We can rewrite this as half times pi into r sine 22.5 the whole square, since x is equal to r sine 22.5. So the area of the semicircle is equal to pi r square sine square 22.5 degrees over 2. Now we have 8 such semicircles. So we multiply this particular expression with 8. So we get 8 by 2 pi r square sine square 22.5. So this gives us 4. So area of all the 8 semicircles is equal to 4 pi r square sine square 22.5. Now we find out the area of the circle, which is nothing but pi r square. So we take this expression in the numerator and this expression in the denominator to find out the ratio of the total area of the 8 semicircles to the area of the circle. So the ratio out here would be 4 pi r square sine square 22.5 degrees over pi r square. So pi r square gets cancelled, and we have the ratio as 4 sine square 22.5 is to 1, and this is our final answer, which is given by option H.